right, SM3, this lesson is chapter 3.8. This is our last chapter. And I was going to cut it into two pieces, but there's part of the chapter we're actually not going to cover it all. So I'm going to be doing this all in one shot. But it is analyzing graphs of polynomial functions. Okay, so remember this picture I had up before? This represented the x-axis, and these are the roots and all that kind of stuff. I'm hoping that jogs your memory a little bit. What are four equivalent things that this represents, okay, in a polynomial? Okay, we've got the zeros of a function, okay? We also have the roots. That's the whole purpose of that picture of the tree, right? We've got roots. We've also got the solutions of the polynomial and the x-intercepts. Okay, so all four of these things mean exactly the same thing. Roots, zeros, solutions, and the x-intercepts. They're all the same things. Okay, some of this I'm skipping because we're not in class together. Okay, so using x-intercepts to graph a polynomial function. All right, so this is already factored for us, hooray, okay? But I look here and I see, what are my zeros? I have x equals -3 and x equals 2. So here are my zeros, -3 and 2. And what the book tells you to do is to take those and look at some values that are around these. So -2, -1, I have 0, 1, and 3 because I know what 2 is. And I also know, okay, this is really important, I've got an x here and an x squared here. So I have a total of 3 x's, 1 right here and basically 2 right here. So this polynomial is of degree 3. And it's positive, so I know that it's basically going to look like that. All right, so let's look at what we've got. Some of these, I've already plotted these. So -2 is 8/3, which is almost 3. So -2 is almost 3. -1 is 3. 0 is 2. 1 is 2/3, which is about right there. Now another thing I hope you notice is we have a double right here. So this is actually, we've got, if it's of degree 3, it means I have to have 3 zeros, right? So I've got -3, 2, and the 2 comes twice. So it's going to bounce off of this 2. So we're coming up like this, it comes down like this, bounces off, and keeps on going. Okay, but remember it's of degree 3 and we have a double here, so it bounces. Okay, so what if it's not factored for us? And what if we're looking at it and it looks like factoring is going to be a real pain? Okay, there is this really awesome thing called the location principle. So if f is a polynomial function and a and b are 2 real numbers, okay, I need to read this because it's the official math language, but I'll tell you what it means in a second. Okay, are 2 real numbers such that f of a is negative, is less than 0, and f of b is positive, then f has at least 1 real 0 between a and b. So in other words, plot a few points. If you find 2 in a row with opposite signs, there's a 0 between them. So let me show you an example so that you can see what that means. So we have, find all the real zeros of 6x cubed plus 5x squared minus 17x minus 6. So what they're saying is plot a few points. So when x is 0, y is -6. When x is 1, y is -12. When x is 2, y, or f of x, is 28. If you look right here, I'm going from negative to positive. If we were to graph this, I have 0, 0, negative 6 is like, say, down here. 1 is negative 12, which is like clear down here. But 2 is clear up here. So this is going somehow like this. So the 0 is between negative 12 and 28, because it has to go through 0. Negative 12 has to go through 0 to get to 28. The line has to go through there. That's what I meant to say. Okay, so let's look at some of our possible roots to this. We've got plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, all over the same factors. But I'm looking for one specifically that's between 1 and 2. So if I look at, say I look at the ones that are over 2. Okay, I have one. It's right here. 3/2 is in between 1 and 2. So that's 3/2 is 1 1/2. So I'm going to check that and see if that is a 0 of the function. Okay, so this is where we haven't done one of these like this before, but we can take 3/2 and we can use synthetic division. So 6, 5, negative 17, negative 6. I'm going to erase this. So I didn't have to write out everything for the rational root theorem. I was looking specifically for one between 1 and 2. Okay, so I dropped the 6. 6 times 3/2 is 9. Okay, add these together. 3/2 times 14 is 21. Negative 17 plus 21 is 4. And 3/2 times 4 is 6. So 3/2 is a root. And I know because it's in between there. Okay, so let's find the other roots. Now we're down to our x squared. So we've got 6x squared plus 14x plus 4 equals 0. So let's look real quick and see if it's factorable. Okay, I'm going to drop down the 14. 6 times 4 is 24. Is there something that multiplies to give me 24 that adds to give me 14? Yeah, it's 12 and 2. So now I rewrite this. 6x squared plus 12x plus 2x plus 4 equals 0. And I use factoring by grouping. So I can take out a 6x and I'm left with x plus 3. Oh, excuse me, x plus 2. And over here I can factor out a positive 2 and I'm left with x plus 2 over here also. So I've got 6x plus 2 times x plus 2 equals 0. So this is where I'm going to find my other two zeros. Well, one of them is negative 2. So my zeros are 3/2, negative 2. And if I set this one equal to 0, I get x equals negative 2/6, which if I reduce that or simplify that, I have negative 1/3. So these are all of my zeros of this polynomial. Okay, we will go on with more in the next video.